Alright, here's a look at some extra practice problems that might kind of get your mind going. For instance, this simplifying one up front, the idea is to combine it down to something as simple as possible, like single trig function or a product of trig functions. And this one, the first step you might want to take is to write them in terms of the same trig function, like sine and cosine. Good things happen. And then you start looking around for maybe something that, like different identities, like if you combine it a certain way, you'd have an identity, or combine things that you know you can combine, like I can combine these right here pretty easily and then go from there. So I think I'm going to take that route. That seems like a good idea. That would make, and if I turn that around, that'd be 1 minus cosine squared alpha all over sine squared because they have a common denominator. And this is still sine squared alpha over cosine squared alpha. Are you kind of seeing something happen here? That's sine squared there in the numerator again, so we can simplify that. And we're pretty much home free on this one. You see the light at the end of the tunnel? This would be sine squared alpha, I haven't touched that, over cosine squared alpha times what's going to be sine squared alpha again over cosine squared alpha. And what am I doing? Over sine squared. Sorry about that. Just recopied the wrong thing. But those cancel. Now, in this kind of simplifying, I canceled the sine squared, but there's still one in the problem, so I didn't actually eliminate the information that sine squared carries with it. You know, if we were in the solving world, we don't like to eliminate some kind of trig function from the problem entirely, but we still have a sine squared around, so we're good to go. And I can't do anything else. This is 1. So actually, I didn't really need to turn that tangent squared into sine squared over cosine, because now that I'm all done, I'm just going to rewrite it as tangent squared of alpha. Maybe you could have seen that we were just going to work with this from the beginning, but sometimes you don't know until you get started. You just rewrite it, look for identities or things that you can combine easily and move on. Don't forget how to do, these are degrees, there's weird markings on there. This is a double angle identity, so if you recognize that or look at the sheet, you're always looking for identities to rewrite it. This ends up just being the sine of 1 or 210. And if you look on your unit circle, is that a nice angle? 180 and 30 more? Yeah, that's one of our nice angles. So we actually know the sine at 210. The height at 210, it's 30 degrees past 180, so that's negative. You guys have a unit circle, you're looking at negative 1/2. And correct me if I'm wrong, I'm working fast and with my stupid, weird position here I have to be in for my back. Long story, I'll tell you maybe tomorrow or on Monday. Here's the rest of this one. Can you recognize that's an identity of some kind? Sine, cosine. That's the cosine function. So you go cosine of the two parts being signed and cosigned. And the thing that you're doing to them is in cosine is the opposite of what you see there. So this will be pi over 18 minus 5 pi over 18. And then you can combine those. Those are like terms, so negative 4 pi over 18. So yeah, that's what you're taking and actually we can do it either way. The order of those, no, that's good. So cosine of negative 4 pi over 18, and we can simplify that. Do you remember that the cosine of a negative angle is the same as the cosine of a positive angle? So whether it's 4 pi, negative or positive, actually doesn't matter with cosine. So that's a good thing to know, and that helps with this identity. But I can simplify that to 2 pi over 9 if you want to. No big deal on that one. It's not like that's a nice value anyway. Simplifying in number 4, this one is, I think I'd want to rewrite it in terms of sine and cosine, don't you think? Because you get a chance to bust those up. And then you look for ways to simplify from there. You can also, some people might introduce like a 1 minus tangent, down here. I might explore this just for a second. Like I said, there's always more than one way to take it, but I've seen this from a number of you lately. You're like, what if I did that? Because I love difference of squares. When I multiply these together, I'd actually just get 1 minus tangent squared of x, and I like that, so. But then you look at your sheet and you go, oh wait, that's not an identity, and you stop. Don't get too bothered by that kind of thing. I mean, if you put in the wrong thing, if you start off on the wrong path and it doesn't work out, just, all right, back up. Let's go simple and see how it works out for you. So, sorry for the blip there. It kind of jumped past a part. Anyway, this is what I did is wrote it all in sine and cosine, and then I went for common denominators in the numerator and denominator here. So I did the great common denominator trick, and I got the top and the bottom. And notice there's a lot of similarity there. I'm dividing fraction by fraction here, so I'm going to do multiplying by the reciprocal next. And so that means I'm going to multiply, this current numerator. It's going to get kind of tight here, sorry about that. Cosine x sine x, that's the current numerator. And I'm going to multiply that by the reciprocal of the denominator, which is cosine x, and another sine plus cosine, cos x sine x plus sine x. Well, if you're paying attention there, you see those are the same here. Now, I'm eliminating a sine plus cosine of x, but I'm not eliminating that trig function entirely, so we're in pretty good shape there. And then if I take cosine here, cancel with that sine, well, this does simplify to 1 over sine of x. If you're doing this is simplify, so you go as far as you can using the simplify rules, that's good to go. But when you're solving, if you were doing that, we would be worried about, like, dang it, I probably lost one of my solutions in there. But for simplifying, what this means is, hey, 1 over sine x, which you know is cosecant of x. And that's done. But what we can do is graph what we have in number 4, the big blob that you started with, and you can graph cosecant of x, and they will graph the same thing. Solving is different, remember. If you're solving, you're finding when things are equal to each other, means when they intersect with one another, so it's slightly different. So simplifying, you cancel things at will. It's okay. And that's a question that came up on homework. People were like, can I do that now? Remember, in solving, things are a little different. You got to be cautious of cancellation when you're solving. Simplifying, free reign. Do it. Number 5 here. In number 5, I might, instantly go, oh, 1 minus sine squared, cosine squared, that's great. But remember, do it with a goal in mind. That's not going to be our best route necessarily on that one. Also, these trig identities, when they're subtraction like that, they're actually difference of squares. It's 1 minus sine of x and 1 plus sine of x. You can write it as that. Here's the minus 1 again, and here's the 1 minus sine x. See, at least splitting that up became more advantageous this time. And so there's a nice cancellation there, and all that's left is 1 plus sine x minus 1, and you see the 1's cancel now. And we just get sine of x. Pretty slick. The last one here is just, hey, that's a Pythagorean identity. I know that's that's the double angle formula for tangent. So we just go tangent, actually for half angle formula, right? Yep, double angle formula, sorry, for it's double. And so you take 2 times, now the thing that's happening, it's like we have 22.5 is the angle, 2 22.5s. So, pretty slick. And, well, that's advantageous to put it back into regular form, because that's actually tangent of 45. And so, in that last one here, I'm going to go up top because I'm running out of room. And we all know the tangent of 45 is 1. So this little dude is equal to 1. And you can do identities, you go forward and backward. You recognize it in one form, you can always go back to the other form and do it that way. Okay? That's the story on that first page. I have others, but that's part 1, let's say.